Dear students, in continuation of our distribution derivations, after seeing the derivation on the binomial, let me continue with the Poisson distribution. What is the Poisson distribution? It is regarded as the limiting form of the binomial distribution when n is very large. You just observe here, when n is very large. Because for the usual values we are considering the binomial distribution. When n is very large, we need to go for the Poisson distribution. Observe here, when n tending to infinity, that is for higher values of n, we shall go for this distribution. And p is the probability of success as usual. E is very small, p is tending to 0, so that it is tends to a fixed finite constant, say m, that is mu p, mu. Hence p of x equal to m to the power x e to the power minus m divided by x factorial. This is the basic definition of Poisson distribution. I am giving the definition directly here. It is only we shall go for using this definition for the mean and standard deviation, which is known as the Poisson distribution of the random variable. What is p of x here? M to the power x e to the power minus m divided by x factorial. Here we have used the verb when n is very large, that is n tending to infinity. Refer the condition shown here, e to the power minus m, that is for the different values of m, the values goes on either increasing in any manner or decreasing in any manner. Therefore it is e to the power minus m. Next, go for the derivation, the mean and standard deviation of the Poisson distribution. My dear students, refer this condition as a very important. That's why I am putting the star mark. As you have seen in my classroom, we are putting the second star mark here. Therefore, mean mu is equal to, as we seen in the case of binomial distribution, what is that? X is between 0 to infinity. Earlier stage, we have taken x equal to 0 to n. We are taking x equal to 0 to infinity, x into p of x. X is the same thing, and p of x is taken from the definition of the Poisson distribution, m to the power x e to the power minus m divided by x factorial. Therefore, cancellation with this x in the denominator. What is x factorial? We can write x into x minus 1 factorial. Cancellation of x with numerator, simply x minus 1 the denominator, and the summation is between 1 to infinity. Therefore, mu is equal to m into e to the power minus m and m to the power x minus 1. Refer here in the right side of the summation. And here what we are taking, m into m raised to x minus 1, what happens? This term will be simply x m raised to x. We are making some adjustment, keeping e to the power minus m outside, x minus 1 denominator. Therefore, m into e to the power minus m. For the different values of the summation, x equal to 1, what happens? M into m raised to 1 minus 1, that is m raised to 0. What is m raised to 0? 1. That is the first term. Take x equal to 2. X equal to 2 is what? M to the power 2 minus 1, that is m divided by 2 minus 1 factorial, that is 1 factorial, m upon 1 factorial. For x equal to 3, this term will be m square upon 2 factorial. For x equal to 4, m cube upon 3 factorial. Refer the expansion shown under the square bracket. Therefore, the whole expansion reduces to e to the power m. How it is e to the power m? You might have seen this definition while doing the Taylor series expansion in the 3rd semester. You might have seen expansion of e to the power x using Maclaurin series. What is e to the power x? You might have seen 1 plus x upon 1 factorial plus x square upon 2 factorial and so on. The same term I am using here. Instead of x, it is m. Therefore, e to the power minus m, e to the power m is what? Simply e to the power 0, that is m. Therefore, mean mu is given by m. Okay, next come to variance b. What is variance b? Summation is between again 0 to infinity x square p of x minus mu square. This definition is already seen in the case of the binomial distribution. Therefore, consider the first term in the right side, x square p of x equal to, we shall make again x is between 0 to infinity, x into x minus 1 plus x. Therefore, what we are doing, x square we can write x into x minus 1 plus x, and p of x is what? P of x is the definition of the Poisson distribution, m to the power x e to the power minus m divided by x factorial. I am writing here. Therefore, using the addition of the terms, opening the bracket, m raised to x e to the power minus m divided by x minus 2 factorial. How it is? Expansion of x factorial denominator. It will be what? X into x minus 1 into x minus 2 factorial. And x into x minus 1 is cancelled with the numerator. Plus the second term, m to the power x e to the power minus m divided by x minus 1 factorial. How it is? X factorial can be written as x into x minus 1 factorial. Cancellation with the numerator x. Simply denominator will be x minus 1 factorial. Therefore, x square p of x equal to keeping m square e to the power minus m. Refer here, m to the power m to the power x, I can write m to the power x minus 2 into m square. My dear students, refer this adjustment taken in the first term, and keeping e to the power minus m outside. In the right side, it will be after summation. What was that condition? M raised to x minus 2 divided by x minus 2 factorial plus m. This is using the definition of x factorial. This is simply m, because we are taking m square into e to the power minus m outside. Therefore, m square into e to the power minus m, and again using the summation as we did in the mean mu using the Maclaurin series. This is again m equal to 2, it will be 1, m equal to 3, m upon n factorial, m equal to 4, m square upon 2 factorial, and so on, plus m, the last term, using the expansion. Therefore, summation x square p of x equal to what? M square. This definition, the bracketed term reduces to m square into e to the power minus m into e to the power m, as we seen here. Therefore, it is m square plus m, using the resultant in 1, using, that is, the first term in the right side will be replaced by m square plus m. Okay, m square plus m minus mu square. What is mu here from the first derivation? It is m. Therefore, m square plus m minus m square, because it is mu square, mu equal to m. After cancellation, it will be m. Therefore, standard deviation will be what is variance equal to m. Standard deviation is what? Always root of the variance. Therefore, it is root m. Hence, we can conclude that mean mu is equal to m and standard deviation equal to root m. My dear students, from the notes as we have sent here, you just go through the definition. Once what we shall do before going to write, before going to solve the exam, the problems, I mean, make a table, write the mean and standard deviation of the binomial as well as Poisson distribution. Keep in your mind, keep these two definitions readily before going to solve all these examples. Okay, feel free to discuss anything. If you do not understand any of the particular step, just message me. I will give the clarification whatever you need. Okay, therefore go with the standard second derivation in the binomial. After binomial distribution, this will be the Poisson distribution. Thanks.